rectification of AC current to DC current. Let us know what are these AC current and DC current. Current supply can be given by two ways: direct current, alternate current. Direct current is given by chemical cells. Alternate current is given by dynamos. Now let's see how the voltage variation and the direction of this current flow taking place in these two types of power sources. Okay. Here you can see the dry cell. It is a chemical cell. It is connected to the circuit with a fan and the galvanometer. Now you can observe the direction of the galvanometer and the rotation of the fan. Now the fan rotates clockwise. Then the galvanometer indicates the clockwise turns. It indicates the direction of the current flow. So in this cell, the current flows from the positive to negative terminal. Here you can observe the voltage does not vary with the time, and direction also in one direction. If we change the terminals of the battery, the direction changes. Fan rotating anticlockwise, galvanometer indicates anticlockwise, current flows from the positive to negative. So, when changing the terminals of the battery, the current direction changes. But in the battery, current flows in one direction with a constant voltage is a DC current. So, we can give the DC current graph like this. Now, let us observe the alternate current. Here I have connected the dynamo. Now, observe the galvanometer and the rotation of the fan. Now, you can see the indicator is clockwise, anticlockwise, clockwise and anticlockwise. It vibrates as an oscillation. And the fan also does not work properly. It is also vibrating. Why? The current direction changes with the time, because inside the dynamo there is the magnet rotating inside the coil. So, when the magnet rotating, the direction of the poles also changing, so that the direction of the current also changing. So, then let's draw the graph for the alternate current. Now, we can represent the variation of the voltage and the direction through the graph. In this axis, we get the current or voltage. This axis time. We mark the clockwise as positive, anticlockwise as negative. Now, let's observe the galvanometer in slow motion. The current we can mark 1, 2, 0, 1, 2, 3. Okay. Now, from 0 the current increases 1, 2, 3 and reaches the maximum, then backs down 3, 2, 1, 0. Then the anticlockwise 1, 2, 3, reaching the maximum, back to 2, 1, 0. Here we have get the one oscillation graph. This type of current flow is called the alternate current. In this alternate current, direction changes with the time and the voltage variation also observed. When supplying the alternate current, fan does not work properly, we can see. So we have to make this as the DC current. Here we are using the diode. Now here we have fixed the diode. Then the current flows only the clockwise. Then the fan works properly. So how will be the graph? In the circuit we are getting only one side clockwise current. So our graph will be changes. Here we have get the only one side current. This type of rectification is called half wave rectification. Here we are observing a great variation of voltage. There are positions, currents dropping down to 0. In this time, current does not flow. To reduce this voltage variation, we connect a capacitor. This capacitor charges, then capacitor releases the charge. So, the capacitor supplies a small current. When the current drops down to 0 from the alternate supply, capacitor supplies the small current. You can observe that the galvanometer indicator now does not come to 0. It is coming about to 1. So, there is a current supply continuously supplied by the capacitor. So, our graph will be changed like this. So, smoothing this variation is called smoothing. This graph shows half wave rectification, smoothing. Now we want to rectify the full wave. To rectify the full wave, we use a collection of 4 diodes. It is called rectifying bridge. Okay, let's operate the rectifying bridge.